Okay, in this example we're dealing with a pair production. Now remember, we have to be very careful here. Pair production, we'll write it down, is when you have a photon of light, which we're going to use the symbol HF just as a single thing, leading to an electron, in this case, and a positron. That's what we call the nuclear equation, even though there's no nucleus involved there. Now the mathematical version of that is the energy before will be the energy of the photon. So we'll write it down. Energy of photon equals energy needed to make the masses. Okay, right. So the energy of the photon is the energy that's going to be involved, and that's going to be HF. Equals, when we're in equals, this is a maths question. Remember, that's the nuclear equation, this is a maths equation. The energy needed to make the masses. Okay, well, we've two masses, so it's 2 times m of the electron c squared. Because the energy to make an electron is mc squared, but m is the mass of the electron. Now, why have we a 2 in there? Because we're also making a positron. And remember, and this is hugely important that people forget, the mass of a positron and the mass of an electron are the same. Okay, they are the same mass. The only thing that's different is their charge. And their charge is also the same, but has an opposite sign, plus and minus. Right, so we have, this is our formula, so we're in business. No, this is a bizarre one, because, and this is a real example of, look, people are forgetting about pages 46 and 47, okay? On page 46, we have H, okay? We have the mass of the electron, and we have C. The only thing we don't have is F. We have everything on page 46 and 47, okay? I'm going to keep it very simple here. Okay, we're going to stick to 2 decimal places. So, because we don't need to go into any further detail, so 6.6 by 10 to the minus 34 times F equals twice 9.11 by 10 to the minus 31, it's the mass of the electron, by 3.00 by 10 to the power of 8 squared. Okay, I lost my calculator. Okay, so we have now 6.63 by 10 to the minus 34 by F, so it's 2. Okay, so 2 multiplied by 9.1 exponential minus 31 multiplied by 3.00 exponential 8, and lots of you are forgetting to square that. Okay, so let's not forget that, and we get 1.64 by 10 to the minus 13. Yeah, and then to get frequency, we divide both sides by 6.63 by 10 to the minus 34. Very impressive improvement in people rearranging, so well done on that. Okay, so we have 1.64 exponential minus 13 divided by 6.63 exponential minus 34. We're getting 2.47 by 10 to the power of 20. It's frequency, so it's hertz. And loads of you are forgetting units. So I'd like to remember, when you're finished, before you upload and present something, you always go back and check all your answers and have you put in units. Okay, so that's kind of an automatic step that we're going to get good at. And that's it. That's the answer. Now that's solving, or that's getting the frequency. That's a pair production question. A pair annihilation question will be exactly the same, but be very careful. Remember, there will be 2 photons. It'll be 2 mc squared. So pair annihilation, you would have 2 photons. Sorry, you would have 2 energies from the masses, and you're going to get 2 photons. So if it's pair annihilation, the 2's cancel, and you have a slightly different formula. Okay, so just don't get caught in that. You're going to get an example of this and an example of this to work over the weekend anyhow, and we'll see how you get on with them. Okay, but remember, 2 things to remember, and nobody's going to make this error again. Loads of data here and here. Okay, this is a calculator. Okay, there's a c squared there, and loads of us are forgetting to carry it down there. So we're not going to let that happen again. Thanks a million. Bye bye. See you Monday.